Good evening, friends. So, in this series, we are going to discuss a very interesting problems related to graph theory that would help us in developing a thinking towards graph theoretical problems. So, today we are going to start with the first problem, which says that draw all distinct, unlabeled, simple graphs of order 4. So first recall all the terms. Simple graph means that the graph with no loops and multiple edges. So loops would look like something like this. This is a loop. Multiple edges means if there are two vertices, then more than one edge between the same set of vertices. Order 4 means we are looking for a graph with 4 vertices. Unlabeled, why we are thinking of unlabeled? For example, let us consider these two graphs. If I label them, then they might be different, something like this, because you can say that in the first one 2 and 4 are adjacent, 1 and 4 are not adjacent, but in the second one 1 and 4 are adjacent. But if I make them unlabeled, then they are same. So we are looking for distinct, unlabeled, simple graphs of order 4. Now order is fixed. It means that what going to vary is the number of the edges. So I can start with 0 edges. So it means this is my first choice. Now if I add one edge, then it won't disturb the possibilities because there is only one possibility. But now think that how can you introduce one more edge? So there are two ways, clearly two ways. The one way is that you keep one vertex as isolated vertex, and the other way is that there is no isolated vertex. So total 4 possibilities are there. Now let's move to the fifth possibility. So I start with the third one. So with the third one, either I can add an isolated vertex, I can add an edge to the isolated vertex in this way, or I can add in this way. Why 5 and 6 are different? Because in 5 there is no vertex of degree 3, but in 6 there is a vertex of degree 3. Now do you see any other possibility? There is one more possibility. So you make a triangle. This is 7th one and keep one isolated vertex. Now from 4, if you add an edge to make it connected, it would be something like this or something like this. All these two possibilities have already been covered by the case 5, and there is no other possibility. It means that we have 3 unlabeled simple graphs with 3 edges of order 4. Now let's explore more possibilities. So from 5, what I can do is I can move to the 8th one by adding an edge here. There is one more possibility. I can move and add an edge here. Now there is no other possibility. If you try the other possibility, you will get the same graph. Now from the 6th one also, if you try to add an edge, there are possibilities like, so this is 6th one, you can add an edge here, or you can add an edge here. This is same as 9th one, but this is also same as 9th one. Yes, because this one can also be drawn like a triangle and one edge is going out. So it doesn't matter how you draw the graph, but you need to see the properties. All these graphs, there are two vertices of degree 2 one vertex of degree 3, one vertex of degree 1, and this degree 1 vertex is adjacent to degree 3 vertex. This is how all these graphs looks like. Similarly, if you try the 7th one, then from the 7th one also there is only one possibility to add an edge by adding to the isolated vertex. And if you add it like this, then again it would be the same as case 9. So moving further, it means that I got 8 and 9 with 4 edges. Now I have to add one more edge. So in 8 there is only one possibility to add an edge, which looks like this one. In the 9th one also, if you add an edge, either this is how 9th one like, either it would be same as 10th one like this, or it would be you draw it and you make it like this. But you will observe that what exactly happened is that there are two vertices of degree 2 which are not adjacent, while two vertices of degree 3 which are adjacent. Therefore, whatever way you use to add an edge to case 9, you will get case 10 only. Now from case 10, there is only one way to proceed, and that gives us the final graph, because loops and multiple edges are not allowed. It means that there are total 11 unlabeled simple graphs of order 4. So if you like the video, keep looking for the problems. I will keep posting them.